Thank you everyone for joining the ENG webinar for today. Today we have three speakers, Sharath, Sai and Matthew from IBM, who are going to talk about Trustworthy AI. With that, without further ado, let me turn it over to Sharath and team to talk about Trustworthy AI.
Thanks, Dinesh. Go ahead. Oh, yeah. Thanks, Dinesh. I'll just kick it off. I'll do a quick intro so that everybody's clear about what the pain point and problem here is. Then Sai will go into some of the technical details on what's underneath the covers. And then Sharath will go ahead and show a use case. This use case was shown at by IBM at Mobile World Congress, which is one of the primary events that we attend from a telco and media perspective. And then, open it up to any questions at that point in time. So let's just state what the problem is. I think all of us are familiar with the problem is, but just in case there's anybody that's not involved much in this area, just want to highlight this is getting a lot of press, a lot of articles out there. I'll just pick a couple here and there. The Boston Globe has a good article that basically talks about if your AI results and your AI data is incorrect and it's unfair, it's not just a matter of being unfair, it has a huge impact on business. There's been lawsuits against Google about racial profiling because they use the algorithms to determine what videos and data to recommend. But another issue is what you think works today will not work tomorrow. So COVID is a classic example. As soon as the environment changed, and as the environment now changes back, insurance companies made certain predictions about what would happen. All of a sudden, people start driving less, and oh, by the way, it's back to where you might have heard of Zillow flip-flopping. Basically, Zillow had this whole strategy to go ahead and based on AI and data to purchase properties and then sell it back. Didn't work. And we're all familiar with chatbot and the latest announcement by Italy saying we're not going to do it. So this is an issue we're all familiar with, and it impacts our revenue. It has huge regulatory and legal lawsuits that could come up. And of course, ultimately, your brand can be greatly hurt. So if we go to the next chart, Sharath. So let's talk about, at the end of the day, is unreliable data has a huge impact. And all of you are familiar with this. This is some data from Wakefield Research, the amount of time that is wasted, really, in terms of governance, in terms of how we manage everything. And even if you get that, a lot of people are still not confident about the results. And how can we be sure, or how can we at least increase that level of confidence so that individuals who've used this information and use the AI and the underlying data are able to say, yeah, I kind of understand the process. I think it's better than what I perceive it to be. And of course, revenue has a huge impact. So let's go to the next chart. And this is I'll just kick it off at a very high level. And as you think about AI, there are multiple areas you need to be trusting. First is you got to trust the data, the obvious one, right? Garbage in, garbage out. But even if you have the right sort of data, if you don't have the underlying processes that manage and support it, you're going to run into issues. So you've got to have the underlying processes that will support that data that you get. And finally, you're going to be creating a whole set of models. How do you know that those models are accurate? Is there something that you can do to confirm its accuracy? How do you know that new biases are not introduced in the future? There's drifting, etc. And so these are some of the key areas from an overall trustworthy in AI that we will be discussing moving forward. And then on the right hand side, it's just at a very high level, here's kind of what the process is, right? You first find the data. There needs to be trustworthiness in the data that you locate. You need to be trustworthy in the data as you prepare it. And then, of course, you've got to build the models. And then as you deploy it, doesn't mean that it continues to be trustworthy because new biases will be introduced, and that's all part of the monitoring. So this is sort of the overall end-to-end view that we will be presenting. And with that, I'm going to hand it off to Sai, where we'll go ahead and do some talk a bit more about some of the specific details.
Perfect. Thanks, Mathews. Uh, Hi, team. So to begin with, as Mathews mentioned, we need for the trustworthy AI, we need trust in data, trust in models, trust in process. Mathews gave an overview, but let me dig a little deeper into this area and also talk about some of the open source technologies that IBM has come up with. So trustworthy AI needs to start with the underlying data. So what do we mean by trust in data and how do we actually achieve it? Because in today's complex world, data will often be spread across the enterprise in different locations in disparate on-premises, public or private clouds. So strength and trust in AI requires connections to data that is accurate, of high quality, and also to ready for self-service consumption by the right stakeholders. So that's what we're talking about here in the trust in data, because it should answer questions like, is my data of high quality? Is there a single stop place for easily finding data? Because one of the major problems with data is having the right set of data, but not able to find the data within the company and going on in circles, trying to find out where the data is or where to get the data from. And the other thing, some of the other things are, is my data properly governed? Because the right individuals needs to have right access to each and right data, or does everybody have access to each and every data set that is available within the company? So for that, data curation should involve making sure that the data used to build the machine learning models is of high quality, accessible with ease of access, and ability to find usable data according to proper governance to ensure that right people have right access to the right data at the right time. This all of this process leads to self-service data and ease of access, so that facilitates collaboration between right stakeholders and exploration of data to find out what is actually valuable and what is relevant from the to the specific project. Now let's come to trust in models. So once we have the data, and once we trust the data, next thing is to actually build the models on these data. Are the questions that we should be answering or we should be asking about trust in models is, are your models trustworthy? Are they free from bias? Are they explainable, or are they just black box models and we don't know what made the model to come to a specific decision? Are the models robust enough to handle changing parameters? Because as soon as we put the model into production, the parameters change and we can get a completely different set of data, but we should be adapting our models to ensure that it handles the changing parameters. And also, can the model be automated? So all the models that are worthy of trust, as you can see here, needs to have the following attributes: fairness. Machine learning models can yield because of bias in the training data, or depending on the models that data that we are using to train the machine learning models, they can yield unfair models or biased models to provide or results to create results that are biased against a certain population or certain privileged group of individuals or privileged groups, so that this machine learning models or this machine learning models that we're creating needs to be fair enough so that it's equal to all groups and not privileged to a certain groups. So that is what we talk about when we talk about fairness. And explainable, like I mentioned, are your models actually explainable in terms of why the machine learning model is coming to a specific decision, or is it a black box where you give the transaction or the value, but we don't know how the actual output is coming from the machine learning model? Because Europe's GDPR laws, as we all know, provide a robust right to explanation for all the decisions reached by machine learning models, and also the Equal Credit Opportunity Act in the US also requires specific explanations for the credit application denied by the AI model. So having the explainability or creating this explainable machine learning models to know how your machine learning model is coming to a specific decision is really crucial to have trust in models also. And when we talk about robustness, we need to talk about how organizations need to be able to understand the impact of changing realities. As I mentioned earlier, these machine learning models and the AI models need to accommodate to the changing parameters, because they usually suffer from model drift. We can have a training data set, we can create a machine learning model, but as soon as the model goes into production, it might have moved away from accurately representing the reality, because the runtime data or the production data that goes into the machine learning model for the prediction might be completely different to the training data. So are your models robust enough to handle this drift? Uh, and once we have all of this, we need to be talking about how to automate this machine learning models, because Model orchestration is all about repeatability and automation. When fresh training data is available, can these models be retrained as and when needed on demand and can be deployed as and when needed? So parameters like these, fairness, explainability, robustness, and automation define the trust in models. Now that we have the data, trust in data, we talked about how a model can be trusted. Let's talk about trust in process also. Across the model lifecycle, from model building to deploying, managing, monitoring, lack of automated process can lead to inconsistency and inefficiency, and also lack of transparency also. So trust in process is all about removing user error to ensure a stable operation. It needs to address the need for AI governance with automation at each stage of AI lifecycle, with the automated collection of facts, lineage, governance throughout the process, and also consistent process validation. And when we talk about trust in process, it can be achieved by following that, automating the metadata tracking of everything that contributed to model, and also capturing the key model facts and metrics so that it can be used whenever we need more information about how the machine learning model has been created and what are the key facts and metrics for this machine learning model. Also providing lineage at scale. By lineage, I mean providing that transparency across machine learning models on where the model is progressing, what kind of data is used for building this model, etc. also needs to be enabled so that we know that we can trust this machine learning model, we can trust this process on how this model is progressing. Also to see, as we talked about how the model needs to be trusted according to all the parameters about fairness, explainability, we also want to talk about how to validate this model and to see if the model is validated, can it be trusted, or can it be put into production, or does it need more retraining or more validation to be before we put it into production. So with that, can you move on to the next slide, please, Sharath? So we talked about all of this process, the trust in data, trust in model, trust in process. But how are we actually handling this? To achieve this trustworthiness, we at IBM have launched various open source offerings or toolkits based on some of the IBM products that we have in the IBM technology. And we welcome developers, researchers, data scientists, and innovators to actually use and contribute to it to help advance the theory and practice of responsible AI and trustworthy AI. The next three slides that we'll be talking about in terms of AI explainability, AI fairness, and AI adversarial robustness are based off the open source toolkits released by IBM Research and Mathews. Sharath and I did not actually build this, but we're leveraging some of the open source toolkits in some of the work that we're doing. So let me talk about some of these open source toolboxes here. One of them is the AI Explainability 360, which is an open source, comprehensive open source toolkit that support the interpretability and explainability of machine learning models. So many of the machine learning models are not easily understood, as I mentioned, or as we all know, because the explainability part and the interpretability part for the machine learning models is really crucial, which allows the users to gain insight into the machine learning models' decision-making progress. In fact, 68% of the business leaders believe that customers will demand more explainability from AI in the next 3 years, according to an IBM Institute of Business Value survey. But when it comes to actually decisions made by the models, there is no single approach that works best, because different machine learning models work in different scenarios. So the appropriate choice depends on what kind of persona is actually asking for the explanation, or what and the requirements of the machine learning pipeline also. For this, we've offered, at least with the AI Explainability 360, we offered a collection of algorithms that provide diverse ways of explaining decisions. As I mentioned, this is this is the initial release of AI Explainability, which contains many, I think, which contains about 8 algorithms, including the Boolean decision rules via column generation and generalized linear rule models. Also, both are applicable for classification problems, whereas generalized linear rule models also applies to regression problems. But the idea here is to have machine learning models or the open source toolkit so that people can contribute, can create a community of practice for data scientists, so that data scientists, developers, innovators can actually understand how the algorithmic decisions are being made, and can contribute to this open source toolboxes so that it can grow and have this responsibility and trustworthiness in AI. So let me talk about, if you can go to the next slide, please, Sharath. Let me talk about let me talk about some of the security aspects in terms of this machine learning models, where we are talking about securing AI against these adversarial threats. We've seen tremendous advancements in development of AI, and many of these breakthrough results in achieving human level performance and cognitive tasks are based on deep neural networks, DNNs. DNNs are complex machine learning models, but bearing certain similarity with the interconnected neurons in the human brain. These are uh, these have reached tremendous advances in the current world, but some of the examples called adversarial examples are inputs where the images or the tasks are actually deliberately modified to produce a different response or desired response by DNNs, which the attackers use in various scenarios to be able to alter the machine learning models responses and also create chaos. So often the target for this adversarial example is misclassification or specific incorrect prediction, which would actually benefit an attacker. So what we're doing with this toolbox is creating this adversarial robustness 360 toolbox to ensure that we are defending against the state of art. We're using the state of art algorithms to defend against this DNNs, the adversarial robustness attacks. And how are we doing this is the approach for defending DNNs are threefold. One is measuring model robustness by finding out the outcomes, by finding out the robustness of the model. We can actually find out if the model is in a good condition or not. We can assess the robustness of a given DNN by recording the loss of accuracy on adversarially altered input. So based on that, we can find out if the DNN is actually fit to be continued in effect. And the other thing is model hardening. By hardening the DNN, we can also make it more robust against attacks and adversarial inputs. So we're also talking about runtime detection, where we typically exploit adversarial inputs typically exploit abnormal activations in the internal layers of DNN. So runtime methods can be applied to flag any inputs that actually trigger these abnormal activations, and can also be altered to ensure that it can be tampered so that we can defend against these adversarial inputs. The ambition of this toolbox is also to create an ecosystem of contributors, both from industry and academia, to defend against such security threats, so that it can flourish and create this community of the community of machine learning models to defend against this adversarial threats. So with that, let me take to the next slide. Now we talked about the explainability and the security, but let me talk about how to create the fairness also using this fairness toolkit that we have as another open source toolkit, which basically which actually checks to mitigate unwanted bias in datasets and also machine learning models. And usually when we mean bias in machine learning models, we talk about bias in training data due to either prejudice in labels or undersampling or oversampling, which yields models with unwanted bias. So this initial release that we have with IBM, the AI Fairness 360, contains about 9 different algorithms developed by broader algorithmic fairness research community to mitigate that unwanted bias. If interested, please check out some of the demos that we have in the references section. Also, we can post the links in the chat here. But basically, the idea is to check out the page and also have the toolkit, which has many algorithms that can be contributed, can be developed, or collaborated to have more and more algorithms to be able to identify this fairness 360. So with that, let me hand it over to Sharath, who's actually going to show a short demo on how Trustworthy AI and MLOPs is applied using IBM technology using a customer churn scenario.
Thanks, Sai. So, the three algorithms or the three toolkits that Sai showed, they were all based on open source. But for this next section, I'm going to show you a trustworthy AI example from the telecom industry. In this particular example, I'll be using IBM products. So not the open source version that Sai just spoke about. And we'll see how this trustworthy AI concepts can be applied to the telecom industry for a particular problem around customer churn. The average customer churn in the US for some of these service providers is as high as about 21%. Um, and customer acquisition cost is about 5x cost when compared to existing customer retention. So it is still a big problem for the telcos. And so a lot of the times the telcos they have a machine learning model to help prevent churn. And building these machine learning models that can predict churn can help the telcos take steps to retain their existing customers. However, doing so in trustworthy AI platform will also avoid things like damage to brand. They will also avoid, or prevent regulatory fines and loss of revenue or some of the other points that Mathews was stating at the beginning of this presentation. So in our Trustworthy AI platform, we show how we need to have trust in data by showcasing our proactive data observability capabilities throughout the data pipelines. We show how irrespective of where your data is, you can extract, transform, and load the data into a catalog. And when you have the data in a catalog, you can put the right kind of governance rules in place so that only the right people have the right access to the data at the right time. And once we have that governance in place, some of the data scientists on the team can then start building machine learning models. And to build some of these machine learning models, we have a number of different tools, but really the important thing is once these models are ready, they need to be deployed. And when they're deployed, we want to monitor them for things like bias and for drift. And also we want to ensure that these models have uh, a way to explain how they reach to the results that they are showcasing. So that's our MLOps and Trustworthy AI platform. With that, let me go to a quick demo. Again, this is just a real short version of a full-fledged demo that we were showcasing at Mobile World Congress, as Mathews was mentioning. And what you're seeing now on the screen is like a sample dashboard of something that a telco executive might be seeing. It's a churn dashboard, and you can see here there are some issues with this dashboard. Maybe all of the data is not coming through. There's some broken data pipeline, so the dashboard is not running correctly. And also, the revenue that is estimated to be of loss here is about 800 million, which when a telco executive sees that, he might start to doubt it. I mean, that seems like a really high number with the estimated loss in subscriber. So he's really doubting, or he or she is really doubting whether the models are really accurate and whether the model can be trusted. So let's,
Is it okay to ask a question?
yeah, please go ahead.
When you showed the dashboard, I was just wondering which of the reports are being generated using an AI model and what type of model, because a lot of them seem like standard analytics report as opposed to something using DNN, etc., that Sai had just discussed.
Right. Yeah. So in this particular dashboard, the one where we're estimating the loss in subscriber, that is the machine learning model that I'm going to show today. So this value that we're seeing here is coming from a model that is saying that these are the number of subscribers that are expected to leave this fictitious telco company.
Okay, thank you so much.
So let's see how we can solve that lack in trust with our MLOps platform. Um, I'm going to go straight to this particular screen where we see we have a number of different data sources across different clouds. We have some customer data on AWS, we have some service data on an IBM cloud, and we have some other billing related data on an on-prem database. And irrespective of where it is, we can bring all of that data together and apply some transformations here. But while you are running these kind of, data pipelines to build the data that's required for you to build that churn model, you want to ensure that you have visibility of the data as it's flowing through the data pipeline. And that's where, this proactive data observability tool that I'm showing here gives you that kind of observability. So as the data is going through, it kind of looks at how much time each of these functions are taking, and if there are, any abnormalities in that, it can quickly flag that issue. And then also you can see, how many rows of data are going through each of these different functions, and any kind of anomalies, it's able to pick it up. So that's the first part a little bit, where we're saying we need to have trust in the data, and we also need to have, observability of this data while it's going through the pipelines. Um, the second thing is about once you actually have the data in your uh, all the data that you need to put it in a catalog so that the right people have the right access. So once you actually put all of your data together in this kind of a catalog, you can have the various users in your organization to look at the data and see what are the business terms associated with certain assets, what are the tags associated, and then just like any review system, right? You have all of these data users looking at the different data sets and reviewing the data sets and saying whether it's a good data set or if there's a particular problem with it. So that's where you build trust within your data sets as well. And you can also apply certain governance rules so that, based on some of the tags, just that certain users have access to certain columns, or they're hidden from certain users. So in this particular case, we're seeing that any data set that is related to billing data, um, for this particular user two, uh, these three columns are obfuscated from him. So he's not able to see who the customer ID is and what are the total charges for that customer ID. Just as an example, right? So this is the way you can apply some governance rules and ensure that the right people have the right access. So that's one section of it. The next section is actually, just building the models itself. So, and we have a number of tools within IBM to build some of these models. This one is called AI. And sorry, Dinesh, I don't know if you can mute some of the users. So this particular model is looking at building a churn model automatically. So what we're doing here is we are uploading the data set that we put together by combining those three different sources. And once we do that, it's able to automatically, read the data set, split it into training and testing data, and it has a number of different algorithms that it can automatically pick up. So based on the data that you've uploaded, it's picking up these two algorithms as the ones that are most relevant, and it's able to build out that churn prediction model here. So once it actually builds this model, we can, quickly save it as a Jupyter notebook. So again, it's not a black box model. It might automatically build the model for you, but you can save it as a Jupyter notebook so that you can see exactly how it built that model. It actually shows all of the Python code. And then, of course, once you see this Jupyter notebook, you can further tweak it as required. And one of the tweaks that I've done here is I've again incorporated the data observability platform into this. So while you're running your machine learning model pipeline, we can have observability of that pipeline. So again, we can look at how much time some of these different functions are taking, and if there is any change in a schema, for example. So I'm going to run this Jupyter notebook again and intentionally, drop a couple of columns in the train data set. And when I run this model again, you'll see that it's able to pick up that issue, that there is an issue in that particular function. And the issue is because a particular schema change was done where a couple of columns were dropped. So while you're running your machine learning pipelines, you can continue to have this kind of observability and you know exactly where an error is occurring. And then, yeah,
Hello.
yeah.
Uh, I just want to ask if this observability thing in ETL as well as like you building the models and all, is that a part of the trustworthy AI or is it a part of like Ato AI or any other service?
So, the way we have put together this is we're saying that, when we showed it through the ETL, the observability shows how you need to have the trust in data. So while you're bringing together all of the different data from the different sources, you can observe that data, and that's how you can have trust in the data while it's flowing through that. And similarly, while you're building your machine learning model, you can observe all of the machine learning pipelines using the data observability platform. And so that helps you build trust in the model and also helps you reduce your mean time to detect and mean time to resolve any issues that you might face when building those machine learning models.
Okay. Yeah. Thanks.
So yeah, once you've built that model and you're fairly happy with it, it's important to actually test it out and validate the model. So you can easily put together either in input format over here or in a JSON format. You just put in a few values and test the model to ensure that you're getting the right kind of prediction. And because you have um, a number of different models or a number of different versions of models, you want to ensure that you can track that model as it goes through the various stages of building a particular model. So you can track it from when it's being developed to deploy, and once you validated it, you then want to put it in production and look at it while you're operating it. And while you're doing that, that's when you want to ensure that there is no issues while it's being monitored in production. And for that, we have another tool that looks at models that are deployed and looks at things like fairness. It looks for quality of the model, as well as if there is any drift in the model itself. So in this particular use case, we're seeing that this particular churn model has a particular uh, bias against the female gender. So we're seeing an alert here, and we can dig deeper into this to find out why there is a bias against the female gender, and there's also an automatic debiased endpoint that can help you look at and prevent you from having bias in your models. And this just ties into the slide that Sai presented earlier. So we have some open source, some of the algorithms in our AI fairness toolkit, and this is how we've incorporated some of that in our product. So sorry,
Could
Dinesh.
you, sorry, one question. Could you just elaborate on what a bias against the female gender in telco churn OS might mean? Is it that
Absolutely. Yeah. So in this particular case, what we're saying as bias is, if you consider two subscribers with all of the attributes being exactly the same, let's say they have the same billing data, they have the same experience with customer and the same network experience, all of the other factors remaining the same. The only difference between these two subscribers is that one is female and one is male. Now, ideally, the model should either say, both of them are going to churn, or both of them are not going to churn, or both of them are, treated the exact same way. But unfortunately, based on, some of the training data, they are, or just, some of the bias that are inbuilt, there might be a tendency where even though all of the factors remain the same, the female might be getting an output that the female is going to churn compared to the male. And the only reason is because of the gender, which ideally should not be a real factor when we're looking at a churn for a particular subscriber. So that is one example of how we're showing that there might be some biases in these models based on the training data, and the open scale platform here can look at that and mitigate that.
Okay, thanks. So just to understand, in this particular model, what you're saying is that the churn model should have the same result if you swap a male for a female in the data. And this particular model basically takes gender into account when predicting churn, which is not supposed to. And that's what you want to do, make sure that's it. Okay, okay, got it. Because I was just a little confused that, you know, uh, bias and churn didn't quite make. Thank you. Thanks for the explanation.
Yeah, no worries. So that was one example of the things that we're monitoring. The other thing we're monitoring is for quality. So, once you develop a model, it's usually, really good initially, but you want to ensure that the model is also good, 3 months down the line or 4 months down the line, because often the conditions keep changing. So this platform allows us to continuously monitor the model, and if there's any drop in accuracy, you can get an alert. And that drop in accuracy, there might be a number of different reasons for that, and we provide some explanations as to why why there is a drop in accuracy. It might be a particular condition that's changed, or it might be a particular you might need to update your data set, etc.
So can you explain how you get the drop in accuracy? Like you're taking the churn model and actually comparing whether or not the user has actually left the company or left the telecom. I was kind of uh, can just explain because it's getting a day by day accuracy prediction. Is that
Correct.
is that what it is? Like no.
Exactly, yeah. So this is when we are monitoring the model in production.
Mhm.
So we can continuously keep monitoring whether there is, subscribers who are churning, and you can evaluate that and then see how good your model is doing.
Okay. So I was just wondering, like, do you have a way to figure out whether a subscriber had churned or a subscriber is just not active for a while on a day by day basis? Is there a way to, or is that kind of built into this evaluation methodology?
Yeah, it's kind of built into this evaluation methodology.
Uh,
Yeah.
okay, thank you.
So that's how we do the evaluation. The other thing which I'm not really showing here is explainability, because oftentimes, as I was saying before, the model turns out a particular output that this particular subscriber is going to churn, but it doesn't give any explanation as to why that particular subscriber is going to churn. So we can look at what are all the factors that are behind that prediction, and then see how a telecom company might change some of those factors so that a particular subscriber is not going to churn. And then we just go back with this, end dashboard again. And then if we highlight the particular model now, we're just saying that the model's a lot more trustworthy here, and the values that it's suggesting are a lot more believable. So because we've now had trust in the data throughout the process, and we also now can trust the models themselves itself. So hopefully, that gave you an idea of trustworthy AI. And we have a number of different references because a lot of this work, at least the open source work, a lot of it has been done by IBM Research. So we've called out all of these references.
Okay. So, Sharon, one question, like, no, you described it in the context of a telco, but I assume the same toolkits, the same things can be used for other type of models as well, or is there something telco specific in the Trustworthy AI platform?
Absolutely. This is just one example, but this same platform can be applied to a whole number of different industries. One other example, for example, is a banking example. When a particular customer goes to a bank and applies for a loan, you want to ensure that there is no bias against, customers at a bank. But yeah, it's applicable in a wide range of industries.
Okay. And I guess then for the type of things that, say, the enterprise neurosystem group is doing with the aim for climate folks, like, monitoring acoustic data or monitoring some fishery data, the same type of approach can be possibly be used or to combine which model can be trusted more or what the model quality is as we apply the AI models to those.
Absolutely.
Thank you. Okay,
Yeah.
let me